Problem statement. If the friction factor F is 0.024 and the reservoir's elevation difference is 80 meters, what is the flow rate through the pipe in the figure below? So the question here is, what is the flow rate? The flow rate Q. So here we have a local losses and we have a friction losses due to the pipe length. So in this type of problems, we should think about using the equation of energy um, because we have a head losses. So now we have to pick 2 points in the system to apply the equation of energy. And 2 points that make sense or is simpler to apply the equation of energy is the top of the reservoirs or the free surface of the reservoir. So I can choose this point 1 and then here point 2. And the reason I am choosing those points is because the pressures at points 1 and 2 are atmospheric, so that can simplify the problem. And also because the velocities at 1 and at 2 are equal to 0. That's going to simplify the problem. So the equation of energy between 1 and 2 will be equal to pressure in 1 gamma plus velocity 1 squared divided by 2 times gravity plus theta 1 is equal to pressure 2 gamma plus velocity 2 squared divided by 2 times gravity plus the elevation of 2 plus the local losses and the friction losses, and that is sum of k plus FLD times the velocity head. Okay, so the pressure in 1 and the pressure in 2 are equal to atmospheric, and they can cancel. The velocity in 1 and the velocity in 2 are negligible, close to 0, so also they can be cancelled. So we can say close to 0. And here we have a theta 1 minus theta 2, and that, according to the condition of the problem, is 80 meters. So the reservoir's elevation difference is 80 meters. So theta 1 minus theta 2 is equal to 80 meters. So we can write down then this one. Theta 1 minus theta 2 is 80 meters, and this is equal to the sum of coefficients of local losses, sum of k. In this case, we have the valve, which with a coefficient of 1.0. We have the entrance coefficient 0.8, and we have an exit loss 1.0. So the sum will be 1 plus 1, 2 plus 0.8 is 2.8. So it's going to be 2.8 plus the friction factor. The friction factor in this problem is 0.024. 0.024 times the pipe length. The pipe length is 2000 and the diameter is 0.8 times the velocity squared divided by 2 times gravity, which is 9.8 or 9.81. So here the only unknown is the velocity, and the velocity gives us a value of 5.0 meters per second. And the flow discharge, which is equal to the area times the velocity, so will give us the following. Area will be pi times diameter square, so 0.8 squared divided by 4 times the velocity. And this will give me a value of 2.51 cubic meters per second. So the flow discharge through the pipe is going to be 2.51 cubic meters per second.